Imagine this. You're sitting on your couch, phone in hand. You open your browser, type in youtube.com and hit enter. Within seconds, videos, thumbnails, colors, animations, the whole page loads in front of your eyes. But what actually just happened behind the scenes? Most people assume it's simple. You enter a web address and boom, it appears. But that moment triggers a massive chain reaction, a network of computers, servers, and communication protocols, all working together to deliver the right data to your screen. And this isn't magic, it's technology, real physical infrastructure that spans the globe. The browser, DNS, IP addresses, data packets, they all work in harmony in milliseconds to make one simple click possible. In this video, we'll explore what actually happens when you visit a website, from domain names to DNS lookups, IP addresses to routing, server responses, and finally how your browser renders everything you see. This is the digital lens, where complex tech becomes simple. Let's start at the beginning. What you type into the browser, the domain name. Let's say you type in www.youtube.com. This is what humans understand. It's readable, memorable, it's a name. But computers don't work with names, they speak in numbers, IP addresses. And they need to translate your nice-looking domain into a machine-readable IP address.
A domain name is just the address to your website. So think of the internet as a vast map full of avenues and streets and turns everywhere. And think of your website as your house. In order for anyone to find their way to your house, even you'll need an address. This address is your domain name.
That's where DNS comes in. Quick real-world comparison. When you want to call someone, you search for their name in your contacts, but your phone doesn't dial mom. It dials a number, like 555-123-4567. DNS is the internet's version of that contact list. The domain name system was created to make the internet usable for humans. Without it, you'd have to memorize strings of numbers to reach websites. Not exactly practical for billions of people. DNS stands for Domain Name System, and it's exactly what it sounds like, a system for resolving names to numbers. When your browser sees youtube.com, it has to ask, what's the IP address for that domain? Sometimes the answer is cached, meaning your device or browser already knows from a recent visit. But if not, the DNS lookup begins.
So let's say that you type in createaprowebsite.com. Whenever you hit enter, your computer sends a request to a bunch of servers that make up the DNS. And DNS just stands for Domain Name System. This domain name system looks up the correct IP address and just points your computer into the right direction. All within less than a millisecond. Wow, the internet is a magical place.
Here's how that process works. First, your browser checks its own memory. Local DNS cache. If it doesn't know, it asks your operating system. If your OS doesn't know, it sends the request to your router. Your router checks its own DNS cache. If it's empty, it sends the query to your ISP's DNS server. That server may then query the root DNS servers, the top of the DNS hierarchy. The root servers point to the correct top-level domain TLD server, based on .com, .org, .net, etc. Then it reaches the authoritative DNS server, which finally gives the IP address for youtube.com. This multi-step query may sound like it takes forever, but it usually happens in 20 to 100 milliseconds. That's faster than a blink. The result is an IP address, like 142.250.190.206. That's the address of a server, one of many, owned by YouTube or its parent company. An IIP address, or Internet Protocol address, is how devices identify and locate each other on the network. It's a series of numbers, and every device online has one. Think of it like a postal system. The domain name is the person you want to send a letter to. The IP address is their exact home address. There are two main types of IP addresses. IPv4. Short and simple, like 192.168.1.1. Still the most common, but space is limited. IPv6, longer and more complex, like 2607-F8B0:4005:805:200E, designed to solve the address exhaustion problem. IPv6 allows for trillions of devices, far more than IPv4 ever could. Now that your browser has the IP address, it needs to get your request to the right server. This is where routing comes into play. The internet is like a giant digital highway system. When your data leaves your device, it doesn't travel in a straight line to its destination. Instead, it hops through multiple networks, often taking the most efficient path in that moment.
IPv4 was created first and is still used by most internet service providers. IPv4 contains 4 blocks of numbers separated by a single dot. And if you Google "what's my IP," you'll probably see that your own IP was created using IPv4. However, IPv4 can generate only 4.3 billion unique IP addresses, and that's nowhere near enough in this digital age. That's why IPv6 came along. IPv6 addresses are made up of 8 blocks of numbers, and each block is written as 4 hexadecimal digits and separated by colons. It can generate enough unique addresses for a galactic empire.
Here's the step-by-step journey. 1. Your browser sends the request to your home router. 2. Your router forwards it to your Internet Service Provider, ISP. 3. Your ISP sends it through regional infrastructure to a backbone network. 4. It may pass through several Internet Exchange Points, IXPs, which connect large data networks. 5. It reaches a data center, or edge node, close to the server. 6. Finally, it hits the web server that hosts the site you're visiting. Every stop is called a hop. Routers along the way examine the destination IP and decide the best next stop. Kind of like passing a message along a relay race. Your request might pass through 5 to 15 hops before it hits its final destination. The server on the other end receives your request. It analyzes what you're asking for, in this case, probably the homepage of YouTube. It retrieves the requested content from storage. The HTML file that defines the page structure, CSS files that control the layout and style, JavaScript files that enable interactivity, images, icons, preview thumbnails, and other visual content. But it doesn't send it back all at once. It breaks everything into data packets, each with a header containing the destination and source IP, a payload with the actual chunk of data, a sequence number to help your browser reassemble the parts. These packets begin the trip back to your device, and they may take completely different routes depending on network congestion and speed. Back at your device, your browser starts receiving the packets and reassembling them like puzzle pieces. Then it goes to work, rendering. The HTML is parsed to create a document object model, DOM. CSS is applied to style the layout. Fonts, colors, spacing. JavaScript is executed to add dynamic functionality. Drop-downs, previews, video controls, images and video elements are loaded, often from external sources or CDNs. Rendering is staggered, which is why you sometimes see a site load in chunks. It's designed for speed. Load core content first, visuals and enhancements later. Modern browsers are incredibly fast. This entire process can take as little as 1 to 3 seconds on a strong connection. To make things faster, the internet relies heavily on caching and CDNS.
Now how CDN works when a user types say www.youtube.com into the browser. So here we have a user who types youtube.com into their browser. The browser sends a request to DNS resolver, which basically looks up the IP address associated with youtube.com. Details of how DNS is resolved is not needed for our purpose, but at a high level, if YouTube did not use CDN, the DNS server would have returned the IP address of youtube.com. But with DNS configured, YouTube will have an alias pointing to www.youtube.cdn.com. That is the domain name of YouTube's CDN server.
Caching stores previously requested content locally. DNS resolutions are cached in your browser, OS, router, and ISP. Site assets are cached, so repeated visits don't need to reload them. CDNs, or content delivery networks, are regional servers that store cached copies of site data. If you're in Atlanta, your request doesn't go to California. It hits a CDN node nearby. This reduces server load, cuts down latency, and improves loading speed for users worldwide. So the next time you hit enter after typing a web address, remember what just happened. Your domain was translated into a machine-readable IP. Your request navigated a network of routers and relays. A server received your request and sent back packets. Your browser reassembled them and built a web page in real time. It's invisible. It's fast. But it's one of the most incredible systems ever built. Now you know how websites actually load. This is the digital lens. If this video helped you visualize the invisible, hit like, subscribe, and share it with someone curious. Got a question? Drop it in the comments. I reply to everyone. See you in the next one.